Number 18. Write the balanced chemical equation for the combustion of methane, which is CH4 gas, to give carbon dioxide and water vapor. And then explain why it's difficult to predict whether delta S is positive or negative for this chemical reaction. Okay, so first let's write our balance equation. We got this. We're talking about combustion, and we have our hydrocarbon here. So we have CH4. That's our hydrocarbon. They told us that it was gas. And remember, with combustion, you always have to add oxygen, right? So that hydrocarbon has to be in the presence of O2 and oxygen gas, right? The air outside. And this will give us carbon dioxide. Carbon dioxide is CO2. That's also a gas. And water, right? So H2O. But they did say that the water was in a vapor form. Vapor is a fancy way for saying gas. So this is just H2O gas. Now let's just center this out. And what good is an equation if it's not balanced? So I'm just going to quickly balance this. Let's just see if it's balanced or not, right? So I have one carbon. I got one carbon. Beautiful. I have 4 hydrogens here. I only have 2 here. So I'm going to just have to put a 2 in front of this to give me 4. And now let's see. I have 2 oxygen plus 2 oxygen. So I have a total of 4 oxygen here. I only have a total of 2 on this side. So I'm going to have to put a 2 in front of here. And now I will just erase this. And the equation's balanced, so now let's get going. Why is this difficult to predict whether that delta S is going to be a positive or negative? Well, when we're talking about delta S's, right, keep in mind that delta S, maybe I'll put that over here. Delta S is just the change in entropy. And when we're talking about the change in entropy, we're talking about the randomness of the molecules inside of the system. Randomness, K-order. K-order. A combination of chaos and disorder. K-order. I do that all the time. I'm surprised I haven't done this more often on these videos, but that's me in real life. I just make up my own words. Anyway, so we have randomness and K-order, aka chaos and disorder, in the system. Now, when we're talking about that, we talk about the states. So in this case, for entropy, it actually doesn't matter that you have CH4, O2, CO2, and H2O. What really matters is that you're talking about the states. And in this case, all across the board, you have gas, 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 and gas. So there is no change of states in here. You're starting off with only gases and you're ending with gases. So I can't really use the solid to liquid to gas, information that we have here to figure out the change in the entropy. So that means that we just have to tally up the total gases. Now for CH4, there was only one CH4. So I have one gas here. Maybe I'll do it like that. There you go. Plus, there was 2 gases. So I have a total on this side of 3 gases. And let's see what's going on this side. Well, CO2, there was 1 in front of it. So I have 1 gas plus 2 gases. You could probably see where this is going. 2 Gs. 1 gas plus 2 gases is a total of 3 gases. And to me, I can't really tell a difference. I have 3 gases starting off, and I'm ending with 3 gases, right? So in this case, I have 3 molecules that are bouncing all over the place. 1, 2, 3. And at the end, I have 3 molecules bouncing all over the place because they're both gases. So that's why it's difficult to predict whether that delta S is positive or negative, because you start, I guess I'll just put it over here. You start and end with 3 gas molecules. So we cannot say that we're becoming more random or less random. Everything is the same. So that's why just looking at it, we can't really predict. In order to find out the entropy value, we would actually have to go into the tables, the appendix at the back of a textbook, get the actual entropy values and do the math, which I think is next section. So hang tight about that. But yeah, as far as this, can't really predict it. Okay? I really hope this helps. Let me know in the comments, subscribe to the channel. Tell your friends, tell your classmates. Thank you so much for that. And good luck on your test. Talk to you later. Bye-bye.